Bismillah. In this video, we set up a private registry for k3s and see how could we debug its configuration from mistyped configurations to even demonstrating different methods for authentication. We'll be going through kubectl, crcitl, and ctr, and how to debug each of them. So let's get started. First, we should be deploying a pod that pulls from a private registry. We could just batch the current deployment or whatever the way we want, but if we have this now configured, we can run the kubectl describe, and most probably if it's a self-signed certificate, would get this log saying image pull back off. Why? Because we need to set up the certificate. So setting up the certificate means that we install it, and we can have a workaround around it, which is setting up a skip verification exception. And this is by getting into the node and modifying the edit to configure rancher k3s registries.yaml and add this file if it's not there, and add these configurations, or modify it and add these configurations. Basically, this is the name of the registry that will be connected to, and after any modifications there, we have to run the systemctl restart k3s. If it's an agent, it's probably k3s-agent. This is how to work around it. After that, we can run the kubectl describe bot again and keep watching it. I would not recommend that. I would recommend doing something that is more debug friendly, much faster than watching the bot and trying to kill it and respawn it, which is, let's try first with the ctr. So we can run sudo ctr, whether we want debug or not, it wouldn't make a big difference. And then we have to use a namespace for the k3s, by default kits.io, and then we can try to pull this image. Unfortunately, ctr does not use the CRI options, so let's explain that and expand on the k3s functionality and how does it generate its configurations. First, k3s is a binary that calls containerd, and it generates the configurations needed for the containerd and spawns containerd. Within these configurations, we'll find that the config.ml is generated, and also we'll find host.ml files generated for each registry. The content of these files are as following. For the config.ml, you'll find many configurations. The main things that we need to take care of here is that most of them are CRI configurations, and that means CTR does not see them. CTR command does not use the CRI. So all these configurations are meaningless for it. It doesn't see it, it doesn't use them. So anything here that we want to use, we have to configure ourselves. And one of the important ones here is the config bus. Later on we'll find that the authentication is also very important for us. For this config bus, we'd need to supply it to the CTR to be able to use it. So let's close this one, and we'll find also the host.email. And here we'll find the skip verify is generated. And for the pull to be working, we need to read this file, but this is stored in the search.d, and we need to supply this directory. The point is CTR by default is looking for a bus like that, etc/containerd/search.d. But this is a sub bus because now containerd is running as a part of k3s. It's running under varlib rancher k3s agent. So that means we need to modify the ctr command and inform it about this different directory. So it's not etc containerd search.d, it's rather varlib rancher k3s agent, it's etc containerd search.d. And this is by adding this host directory. So now we'll be able to pull from this registry while also using the correct directory. Of course, that does not cover the authentication. As we've seen before, authentication is part of the config.ml. For our case, if we want to use the CTR, we would need also to supply the username and the password here. And if we've done all of these steps, we'll be able to successfully pull the image. You'll find that there are many things coming here with the CTR, and that takes us to the next step. But before that, there's one more command that I want to show you here. The CTR can also remove images, and this is very different from the crictl. By default, this can remove the image even if it's being used by a container. For the crictl, this is not the case. So let's jump to crictl. All what we need to do is use crictl pull and the image, and it would be by default respecting the config.toml, which was not the case with CTR and which is very convenient for usage with crictl. For the removal of the images, we can just use crictl remove image, and for listing we can use the same command. And basically I would recommend using crictl for debugging in the future. You just pull the image, ensure it's pulling or it's failing, or yeah, it's more convenient than using the kubectl for debugging the pull back off. So for now, we are not using this authentication yet in the configuration file. So the configuration we have now, or the registry YAML we have now, is only adding the insecure escape verify. What we would get is authentication failure, but we still were able to pull the repo. And that's a workaround. Let's get into the fix. We have two fixes actually. One of them is a system-wide installation, so we can copy the certificate into the certificate store. For example, using Ubuntu, I'm just copying it to user local share CS certificates and then running update CS certificates. Based on your distribution, you have to figure out how to system-wide install the certificates. For the other fix, you can add a certificate per registry. In our scenario, we would be setting something like that in the registries. For now, I induced an error here, so you should be using ca_file, but let's see what happens when we use a wrong key. Now we just restart the k3s and see what happens. It silently fails. So k3s will be restarted, and when we try to pull the image, would get that certificate signed by an unknown authority. So the certificate is there, or the file is there with the intermediate and root certificates. The full chain is there. So it's something that we don't know what's happening here. Yeah, we know in advance, but in reality you don't know that you have a typo here. So what I've done in my situation, I start with openssl, and just to check if this server is verifiable by this certificate, and if I get a verification okay, then we are fine and certificate is good, but the k3s configuration is broken, which was the case here. If it's not, then we need to figure out what is the problem with the certificate and then fix it and then debug here. In our situation, this is not the correct thing, so basically we didn't get a k3s running, but we still have an openssl successful verification. So we go to the other step. As we seen before, we have the host.toml and the config.toml being generated for us. For the CA, we are expecting it to be seen in the host.toml. So just cat the file here, of course with sudo rights, and you'll find that the CA variable is not set. And this means that the CA is not correctly seen. Be careful that it may take a couple of seconds after you restart the k3s for the generation for the code, but in our case, after a couple of seconds, after some time, it's still not generated. So what we do next is to correct the CA_ file, and after that check again, and we can see the CA is generated. You can see here it's an array, even though we just set a file. For the configuration for the registries, you can only set a single file. And then if we try to pull now, you'll find that we are no more getting certificate verification errors. We are now getting authentication errors, and that takes us to the second chapter, which is how to set up the authentication. Authentication can be set up in two ways or even more, but for the current one I'll be discussing basically is the node level. Node level means we set it for the whole node. Whatever registry communication coming through this node, like if any namespace, any pod is trying to get to pull within this node, it would be using this authentication. I do not recommend that because it's less easy to debug, and of course there's a problem here that I'm using a plain text here, but it could be useful based on your situation. Actually, you just supply the username and password in the registries YAML under auth username password. So basically it would be something like that. So registry, and then there's TLS. So in the same level as TLS we have the authentication. And after that, be careful, by the way, this is an important note here, do not escape the $sign. If we have done something like that, k3s would not fail. Containerd would not fail, but it would be giving a broken socket. And the problem here is that it's not easy to detect this issue. You have to get into the general control of k3s and check there'll be an error, but the problem is that it's a silent error. You wouldn't know it unless you have to dig deep into it. You'll find the socket not working, everything will be broken, but this is really, I would say, it's a serious issue if you add escape slash here. So if we try to pull afterwards, it would be successful. And the second way, which I would recommend, is to use a namespace level secrets. So basically create secrets and attach image pool secrets into the deployment or the pod so that it can reach the registry. And for that, I'm using Harbor user and Harbor pass. I highly recommend, by the way, that you watch the video for how to create robot accounts from the API to be able to manage these robots. And basically just create a robot and try to authenticate with it through the kubectl create secret. With that set, you can batch the deployment to just add the secret to the deployment, and after that you will be able to pull the image again. And by the way, between these runs I was using the sudo crictl rmi to remove the image and try every time new to ensure that I'm pulling a new image. And of course you can list the images to ensure that you are always having it or not having it, and after that you have the secret deployed. Be careful for the second option. You would need to create a secret per namespace or a service account per namespace. For other fixes for authentication, you can use external secrets, which allows you to use something like HashiCorp Vault or any other secret provider. You can pull on the node from other secret providers. You can mix ways. Basically, you can get a secret to be pulled into the node and then use it from there. There are many options here. For the references, I highly recommend that you check the k3s private registry documentations, the containerd. It has lots of configurations about host.md and the CTR options, and also there are extra things that I found useful while debugging. Could use the config2ml.template to template the config.tml, but be careful, this replaces the configuration file totally. It does not just extend it. Thanks for watching, and I hope this video is useful for you for debugging further issues with the private registries.